Magnets and magnetism. The futuristic-looking train in the figure below is called a maglev train. The word maglev stands for magnetic levitation. Magnets push the train upward so it hovers or levitates above the track without actually touching it. This eliminates most of the friction acting against the train when it moves. Other magnets pull the train forward along the track. Because of these magnets, the train can go very fast. It can fly over the countryside at speeds up to 480 kilometers or 300 miles per hour. What are magnets and how do they exert such force? In this lesson, you'll find out. Properties of magnets. A magnet is an object that attracts certain materials such as iron. You're probably familiar with common bar magnets, like the one in the figure below. Like all magnets, this bar magnet has a north and a south pole and attracts objects like paperclip that contain iron. Magnetic poles. All magnets have two magnetic poles. The poles are regions where the magnet is the strongest. The poles are called north and south because they always line up with Earth's north-south axis if the magnet is allowed to move freely. Earth's axis is an imaginary line around which the planet rotates. How do you suppose, or what do you suppose would happen if you cut the bar magnet in the figure above in half along the line between the north and the south poles? Both halves would also have north and south poles. If you cut each of the halves in half, all of those pieces would have north and south poles as well. Pieces of a magnet always have both north and south poles, no matter how many times you cut it. Magnetic force. The force that a magnet exerts on a certain material is called a magnetic force. Like electric force, magnetic force is exerted over a distance and includes a force of attraction and repulsion. North and south poles of two magnets attract each other, while two north poles or two south poles repel each other. The material a magnet is made up of, the size of the magnet, the orientation of the magnet, and the distance the magnet is away from a given material can all affect the strength and direction of the magnetic force. Look at the diagram below to see how these variables can affect the strength of the magnetic force. The diagram uses arrows to represent force. The length of the arrow tells how strong the force is. The direction of the arrow shows the direction of the force.